a better world together. Rabobank.
Welcome back to the second session of JSpring Digital on our third day in a row, where I'm very pleased and proud to announce our next speaker, which is Graeme Rocher. Graeme Rocher, the creator of the popular open source framework Grails, and also Micronaut, and author of the book The Definitive Guide to Grails. Today, Graeme will unveil deep secrets of the framework Micronaut he's written. So, Graeme, take it away. Enjoy.
Thank you very much. Pleasure to be here at JSpring Digital. As mentioned, I'm going to be doing a deep dive into Micronaut for those of you who are not familiar with it. And for those of you who are not familiar with me, my name is Graeme Rocher, as mentioned, and I created a couple of relatively well-known frameworks in the Java ecosystem in Grails, which is now 13 years old, and more recently Micronaut. I'm a principal engineer at Object Computing, which is a fantastic company that contributes significantly to open source, including to projects like Groovy, to Grails, and to Micronaut. And I am a Java champion and happen to win a Groundbreaker award as well. So on the agenda for today, we'll do an introduction to Micronaut, motivations for its existence. We'll look at Micronaut's approach to solving different problems. And like most of my presentations, for those of you who have ever seen one of my presentations, I'm going to be heavily focused on doing a lot of demos, a lot of live coding, and hopefully the demo gods are with me. So for those of you unfamiliar with what Micronaut is, it is a primarily microservice and serverless focused framework, hence the name. However, it is a complete application framework for any type of application, really. Although Micronaut definitely has an inclination for microservices and serverless and has definite concrete strengths there. We have teams at Object Computing that are using Micronaut to build, for example, swing applications or command line applications and so forth. Fundamentally, what Micronaut does is it provides what I call the kind of building blocks, fundamental building blocks of a framework, which is dependency injection, aspect-oriented programming, configuration management, bean introspection, and more. And those are the building blocks that you need to build a framework with any framework, really. And with Micronaut, as I mentioned, you can build microservices and serverless applications, like as I mentioned, but you can also build a whole different types of applications. So you can build, for example, completely headless message-driven applications that just listen to Kafka streams or RabbitMQ queues. You can build command line applications. You can even build Android applications with Micronaut, as we support Java 8, and because we don't use reflection, it works well on Android. Pretty much anything with a static void main you can build with Micronaut. So what is Micronaut really? We like to think of it as like an application framework for the future. The last 10 years was, about the kind of framework design that we used was based around reflection and runtime bytecode generation. We believe for the next 10 years, framework design is very much going to shift towards reflection-free approaches, runtime proxy-free, free of bytecode generation at runtime, free of dynamic class loading. And there's a lot of reasons to avoid those things, and I'll just talk about some of those during the course of this presentation. Micronaut also features a bunch of like APIs that helps you move more and more logic into your compiler rather than into your rather than waiting until runtime. And lots of parts of Micronaut use those APIs. For example, we have support for Swagger or Open API generation at compile time. We have support for a whole bunch of things at compile time that essentially shifted. And of course, yes, it does let you build microservices, as mentioned. So why Micronaut? Why now? So, you know, when we started building Micronaut, there were definite challenges, and there still are definite challenges for using Java in serverless and microservice scenarios. Existing tools and frameworks were not really optimized for cold starts, low memory footprint scenarios, particularly with things like containerization, Docker, and so forth. And you know, languages like Go. A lot of folks have looked to languages like Go and JavaScript with Node to provide better solutions in this regard. And you know, it's my belief that, you know, the Java ecosystem is still the strongest out there, and there's a lot of the problems in the Java space are down to the way that tools and frameworks have been designed, and it's just a matter of adapting those. And one of the fundamental things that we're trying to move away from in Micronaut in particular is to eliminate the use of reflection in server-side Java. So I specifically say server-side Java because reflection is not typically used in Android-based frameworks, which have already made this move. And the reason why reflection is a problem is quite clear if you look at the source code for the OpenJDK or any version of Java. This happens to point to Java 8, but any version of Java is the same. And the reason it's problematic is because the minute you access any reflected data on a class, whether it be a field or a constructor or a method or whatever it may be, all of the reflected data for that class is initialized and stored in soft references. These soft references are not garbage collected until your application is actually low on memory. And now if you think about that for a moment, every field, every method, every constructor. So essentially there's a correlation between the size of your class file and the amount of memory that's going to occupy. And typically when you think about a framework, you know, if you think of something like, for example, JAX-RS, where, you know, JAX-RS is only really interested in the methods that are annotated with @get or @put or @post. It's not really interested in the other methods, but still we have to pay the cost of initializing all of those methods, all of those fields into reflective caches. And that's why in Micronaut, we have a strong focus from the very beginning of completely eliminating the use of reflection at the framework level, because if you don't, in my view, it leads to essentially uncontrolled memory requirements, where you cannot control how much memory the end user's application is going to occupy, because it's in their hands. It depends on how many methods or how many fields that they declare. So Micronaut, you know, we announced it in March 2018, and it's had an absolutely massive impact on server-side Java already. It was open sourced on 20th of May 2018, and it's pretty much, you know, changed the way developers and framework developers and the industry views how frameworks should perform in terms of memory consumption and startup time. And you have companies like Red Hat, which have, you know, essentially copied Micronaut's approach with Quarkus, and Spring Boot essentially trying to make improvements in terms of startup time to in Spring Boot 2.2 and above. I think even in 2.3 they tried to improve. So Micronaut has really made a massive impact in terms of like trying to change the face of server-side Java and influence greatly the industry. And there's a lot of excitement about it, and we're pleased with the progress it's made so far. Another technology which was open sourced and announced after Micronaut, after we open sourced Micronaut, is GraalVM. which is a universal virtual machine from Oracle. And it happened to have, when it was announced, I looked at it and it happened to have this tool called Native Image, which essentially used closed world static analysis to produce a ahead of time compiled native image from Java code. And it can, in order to get native image working with GraalVM, you have to, if you use any reflection or any dynamic class loading or any runtime bytecode generation or any of those things, you have to provide configuration to the native image tool to deal with those cases. And it just so happened that we weren't doing any of those things with Micronaut. We were not doing reflection. We were not doing dynamic class loading. We were not doing runtime bytecode generation. We were not doing any of the typical things that GraalVM requires configuration for. So Micronaut just kind of worked out of the box with GraalVM and still does. And with native image, any Micronaut application that you build is automatically compatible with GraalVM native image. The only problematic area may arise if you involve a third-party library that's not yet configured for native image. And even in that space in Micronaut 2, we're really improving in that area. So and a native image really does provide a significant boost, in particular for certain types of applications. So for serverless applications and for command line applications, the startup time of like 20 milliseconds with Micronaut, for example, provides insane benefits in terms of if you're going fully serverless. So there's been a lot of interest in Micronaut and GraalVM together for obvious reasons. And it's an awesome project to keep an eye on, GraalVM. But it's important to note that Micronaut optimizes for GraalVM native image, but it also the same things that make Micronaut Grail great for native image are also great for regular Java, because we're saving you memory and we're reducing your memory consumption, your startup time. We've had customers on Micronaut who have told us that their cloud spend has been reduced by 50% by switching from another framework to Micronaut. Because it completely eliminates reflection, which is really, really important for memory savings. So cycling back to Micronaut's problems for framework developers, and the reason why framework development has been in the way in the last 10 years, it really comes down to a few areas of limitations in Java, which make it challenging for framework developers to build something at runtime. Some of those things are, for example, Java has a very limited annotation API. And what I mean by that is, for example, if there's an annotation API in Java, but it doesn't let you find out, does this class implement an interface that has this annotation, or is this annotation annotated with another annotation? So the whole merging of meta annotations and inheriting annotations from interfaces or superclasses is completely left down to framework developers to implement, which makes it extremely challenging to do that in a performant manner. And it's remarkable what the Spring team has actually achieved to make that performant. And type erasure is also really a challenging thing for framework developers. So for example, I have this list of string, and I know it's a list of string, but when I get a reference to it, it's the string type is gone, which provides, and there's amazing amounts of code written to deal with resolving generic types within modern frameworks. A reflection I've already talked about, and the other problem related to reflection is reflective data caches. So if all your frameworks use reflection, what typically happens is something like this, where you're using, say, for example, Hibernate, and Hibernate has its own reflective data cache for the entities that it has to read and write to the database. So that's one cache. Then you're using something like Jackson to write JSON to the response. That has its own reflective data cache. So you have another cache of reflective data for Jackson. Then you're using something like Spring, which has to, reflectively read bean definitions from the path, and that has another reflective data cache. So you have all these data caches for reflection spread all over the place, which, because essentially reading reflective data is expensive, which contributes again to leading to more memory consumption and problems in terms of performance and memory consumption. So that's again something that's rather limiting from a Java framework developer's perspective. And another area that is challenging for framework developers is finding out what something is, what is annotated with what. So imagine, for example, JAX-RS or something, or Hibernate. Hibernate has to find out all of the classes that are annotated with @entity. So the typical way to do that is to scan the class path, and obviously that's really expensive because you have to do a lot of file I/O and search through the class path and so forth. So again, that's not ideal. And then depending on a lot of frameworks have really complex class loader hierarchies, which may again, if you're involving dynamic bytecode generation at runtime as well, dynamic class loading can become very slow for framework developers and consume a lot of memory. So all these problems we've tried to address in Micronaut, and what I'm going to do now is do an interactive demo of Micronaut on how we've addressed various types of problems in this area in Micronaut, and demo to you the framework and show you what it can do, and hopefully you take away a good impression of what Micronaut is and what it provides. So to get started, I'm going to switch to my IDE, and what I have in front of me here is a Micronaut application, and you will see that it's structured like a typical application. So I have a build.gradle, although it could be we support Maven as well. We have configuration via application.yaml, although we support application.properties as well. And the way I actually created this application was through Micronaut Launch, which is something that we're actually releasing as part of Micronaut 2. So if you're interested in having a look at that, you can go to launch.micronaut.io. And this is the site, and this allows you to essentially generate a Micronaut application. So what you can do is essentially make the font bigger so you can see things. You can select the application type. So for example, a regular application or a command line application, or we support gRPC, we support messaging applications or serverless functions. And you can choose your language, whether it be Kotlin or Groovy or Java. Your build tool can be Gradle or Maven, and your testing framework. And then there's a features button over here where you can say, I want to add some features to this application. And in here, you'll see there's various options to add additional features. So, for example, if I want to add support for Postgres database, I can add that as a feature. And then you have various buttons down here. So the preview button will let you preview what's going to be generated. So, this is a Gradle build. So you'll get your generate Gradle build. You'll see that you can navigate it in here, and that's my application class. And you can also perform a diff of what features you added and what they do. So in the case of Postgres, it just adds a few dependencies, including test containers. And then when you're done, you can click generate to generate the application. So that's how I created this application before. If you don't want to use a web UI, then we also have a command line tool called MN. Which you can use to generate an application completely offline. So, if you ever are again on an airplane one day, you can generate Micronaut applications offline with MN, and you can do so interactively. So I can type NM, and then I can say create app, and then I can give it a name, say example, and you can choose your language. So let's say, for example, Kotlin. You can choose your features. So let's say, for example, I want open API support, and you hit enter, and it creates your app, which you can then cd into and open inside your IDE, like so, and it'll be automatically configured, in this case Kotlin app, and you'll be ready to go. So in this case, I have a pre-created application which I'm going to demo. So I want to talk about some of the things that framework-like things that Micronaut does. So it's typically in a framework that we have, for example, a person class that we want to serialize to JSON or something like that, and they may have, like, for example, a name, and they may have an age, something like that, to make that final as well. And then they may have a constructor that takes those two things and some getters to retrieve those values. And it's typically in Java frameworks that you want to be able to introspect this particular class and instantiate it dynamically, and call the getters and setters and so forth. So for that, in Micronaut, we have what's called an annotation called introspected. And if I add it to my my class, what I get to do is, for example, test person. I can use what's called the bean. I can get hold of the introspection by saying bean introspection.get introspection. And there it is for person. And I can say introspection.instantiate. And in this case, it's, it's going to be the name and the age. That'll give me a thread. And then I can say assert equals thread. So, oops, that's not going to compile. So there you go. What this has achieved is essentially I am able to, without using reflection, instantiate the person class. And I can also use the introspection, for example, to read a specific property. So I can say, I want to read the name property. And I'm going to get a reference to the property, bean property. And I'm going to say property dot get and pass in thread. And you'll see that when I run this test, you'll see that name will print out thread, right? So I'm able to get hold of the property, a reference to the property, in this case name, and call get on the instance of thread to read the property from the object, right? And it's gonna do that. It's gonna do that completely reflection free. And this is one of the kind of fundamental building blocks that we build on with Micronaut, bean introspections, where everything, reading, writing properties and so forth, can be all marshalling the person to JSON is done completely without reflection. So let's have a look at how we may use that person class in a controller, for example. So I'm going to create the person controller like so, and this is going to be a web controller, and it's going to map to people URI, and we're going to have a get endpoint that's going to return a list of person. Do that and see how that works. Okay. Let me make that a bit bigger in case anybody can't see it. So let's turn a list of people. Say one person, Fred, another person, Joe. So, oops, that should be a comma. Another semicolon. So, so there we go. So I've written a controller that's going to return my two person instances as JSON from my people endpoint. So how would I go about testing this in Micronaut? So I already have a person test here. What I can maybe do is create another person controller test. And on this test, I'm going to add Micronaut test. So Micronaut test is the testing framework and toolkit that comes with Micronaut. And when you add it to a Micronaut test to a JUnit test or Spock, we support Spock as well, or Kotlin test, what it does is spin up the Micronaut server inside the test, right? So how would I test my interactions? So what I'm going to do to test it is I'm going to write a person client. That's going to be an interface. So there it is. So this is going and I'm going to use the @client annotation and map it to the people endpoint. And I'm going to say add a get annotation here, and I'm going to get my list of people back, like so. There it is. So this is a way to define a declarative HTTP client. I'm importing io.micronaut.http.annotation, or in this case, io.micronaut.http.client.annotation.client, adding it to this. And at compilation time, Micronaut is going to implement this interface for me. So that's one of the keys here with Micronaut, is that we don't wait until runtime to implement this interface for you. At compilation time, we implement it, which avoids the need to dynamically generate JDK proxies or use reflection or anything like that at runtime, which is really important. So how do I get a reference to this? Let's inject it into my person client test. Create a new constructor and add a test here. People, like so, and then we can say person client dot list the people, and that equals. So I expect it to be 2 people size. So that's the test, right? So let's run that and see what happens. And if the demo gods are with me, then things will work and everything will be happy, which they are. So there you go. Now this is actually a lot going on. This is it's fully spinning up my server. It's making an HTTP invocation to my controller. And so forth. If you don't believe me, you can come into logback.xml, for example, and I can say logger name equals io.micronaut.http.client level equals trace. So I'm going to enable trace logging. And if I run the test again, you'll see that at this time when that executes, you can see the actual HTTP request being made to my server and the JSON response coming back, and everything is fine. Now, one of the huge differences that Micronaut has made to server-side development and of this kind is that you'll notice that this test that I'm running executes instantaneously. There's no like waiting around. Gone are the days where writing an integration test like this one meant that you had to split your unit tests and your integration tests. And there in the past I worked on so many projects where where people have not wanted to write integration tests or functional tests because the server starts too slow, right? That shouldn't be a factor in your decision when writing integration tests. And it's not with Micronaut. Running integration tests is as fast as running a unit test. They're blazing fast. As you can see here, that when I ran that test, it executed in 511 milliseconds. So that's pretty important. So now, that's obviously I'm using a blocking call in my client here. This you could instead substitute into a flowable with RxJava and do reactive type things. So if I do blocking. I think you have to do toList blocking get or something like that. That is going to effectively do the same thing, but if I wanted to, I could subscribe to the results and implement completely non-blocking logic in my client interface. So that's pretty cool. Now, another typical thing that happens in framework development, or that users want to do, is some kind of like AOP advice type thing, and defining AOP advice and those kind of things in other frameworks is really way too much work than it needs to be, and Micronaut makes it like so simple. So for example, say I created another endpoint here called name. I'm going to look up a particular person by name. That's like that. And for the moment, I'm just going to hardcode a response here. Not do anything too clever, so it's not really actually doing anything useful. But what I want to do is write some. This is obviously a very fabricated AOP advice, but I want to write some checking for this argument. Yeah. So how would I do that? So say I created like a new annotation called null check, and this is going to be retention policy. Retention. Yeah, can anybody ever remember the names of these things? Let's just copy something over here. So copying and pasting code. There we go. So it's going to be retention runtime, and this is going to be and I'm going to use the type annotation to indicate a particular interceptor type. And what I'm going to do is I'm going to create a null interceptor, which is going to implement method interceptor. So like so. We're going to implement that method, and at the moment we're just going to do context.proceed. And this is going to be a singleton bean. So at singleton is how you define a particular scope for a bean. So I'm defining an interceptor, a method interceptor for Micronaut AOP that's going to intercept method invocations. And the way you link it together is you say null interceptor.class. So this null check will invoke this null interceptor. And now I can just add null check onto this method. And in theory, we should, if everything goes according to plan, I may actually need some kind of test to way to invoke this method, I guess. So let's add another get request here. Like so. And let's try get person by name. Yes, just get person. See how that works. Okay. So make that bigger. Person client dot get. Cert, not null. No. So let's run that. I assume it's going to pass. I've written a lot of code. I'm a little bit nervous, I must say. It does pass. Now let's put a breakpoint on here, which we already did, and it doesn't get hit. Why is that? So Python controller null check. Breakpoint here. Let's see, what am I missing? I know what I'm missing. You have to declare that this is at around, of course. So that should be at around. So whenever we have different types of advice in Micronaut AOP. So we have around advice, we have introduction advice. So I had to declare that this particular advice is of type around. Yeah, let's see if the demo goes with me for the second time. So let's go. Yeah, so now my interceptor is being hit. As you can see, the way you can intercept the method call and either proceed with the invocation or not. So for example, if I wanted to add some kind of method checking here, I could say context of get parameter values. If parameter value equals null, throw a new illegal argument exception, and no arguments are not allowed. Kind of a silly little AOP advice, but the kind of thing that is very handy is that the framework does properly. And notice now how I've written this interceptor. I've defined the annotation that's going to trigger it, and I'm not having to write any kind of like proxy factory beans or crazy things involving proxies and everything. It just automatically works. Now, obviously, you typically want to involve, like, rather than just like hard-coded lists and stuff like that, you may want to involve a database. So Micronaut has a really great database toolkit, which can work with either JPA or JDBC, called Micronaut Data. So if I wanted to make this person entity a database mapped entity, I can just add a mapped entity onto it, like that. And probably I want to add a ID, like so. This is going to be the ID of the thing, of the entity, like that. And now how would I read and write objects to the database? And what I've done is, for this application, I've set up a H2 database. So it's, it's just connecting remotely to an H2 instance, which I have running in Docker here. And so that's how you configure it. And what I can essentially then do is define a person repository. Let's do that. Repository. And it's going to be an interface, like so. And what I can say is I'm going to make a JDBC repository. And what you have to do is, because Micronaut Data computes all of the queries to execute at compile time, we have to specify a dialect. So we're going to make it into an H2 database, and we're going to extend from CRUD repository and the entity, which has two generic argument types. One is the entity that we're going to use to make queries, which in this case is person. And the other is the ID type, which is long. So you can see that a person has a long ID. And so if, now let's use that repository. So we're going to do constructor injection, person repository. Let's inject it in there. And instead of this, we're going to do person repository.find all. Oh, I can see that's not compiling. I think it's because, yeah, find all returns a list. So it returns an iterable, sorry, and here we're returning a list. So probably the easiest way to do that is just to override the find all method in here and use return a list instead, like so. There we go. And now we have things compiling. So in order to get some data in there, let's get some data into the application on startup. So how would I do that? So I've gone to my application class here. This is my application class, which is used to run the application. That's probably not something I really pointed out in the beginning, but basically, if you want to run the app inside your IDE, you essentially can just run it directly from the application class, which is kind of handy. I tend to write a lot of tests and just run them, but if people want to run the application from the IDE, they can do that right here. Another thing that's useful is that you can drop into terminal and you can do Gradle run /t, which you may want to consider doing if you want. And what that does is essentially, well, I think I have the wrong, application, so that should be JSpring. So Gradle run /t, my application class reference was incorrect. So with that in place, what you can do is essentially with Gradle run /t, if I were to make a change to this class, whenever I make a change, it'll automatically restart the server and reboot it and so forth. So that's one option if you want like the hot reload experience. But I tend to work mainly in like personally running tests and so forth in this manner. Back to you can see when I ran my test people method test is failing because now I've got 0 people returning. So how do I fix that? Let's add a startup event listener. And we're going to listen for the startup event. So whenever the application starts up, this method is going to be invoked. The next thing I can do is inject my person repository into here, like so, and we can do repository.save all and list new person Fred person like that to create some data when we start the app. And now when I run my test, I imagine, yes, it does, it passes. So that's how you essentially save some data. Now I've essentially altered this application to use a database. It has a person repository, which is communicating via the controller. Now, one of the things to keep in mind is when I'm doing mainly kind of blocking operations here, and Micronaut's default server is based on Netty, so that's obviously undesirable. There's a couple of options you can solve that. One option, you can switch to Micronaut servlet, which is we now support servlets. But obviously that's probably not necessarily the ideal solution. In this case, I'm using JDBC, which is a blocking operation. So what you can instead do is say execute on task executors.io, and that'll shift all operations onto the IO thread pool. That's one option that you can do. Another option is instead of returning a list, we can return a flowable from here for my query. And in that case, Micronaut data itself will automatically shift it to the operation in question to the IO thread pool, and we won't be blocking the Netty event loop, which is clearly undesirable. So there are a few things that Micronaut that I haven't pointed out, that because we're doing things at compilation time, make Micronaut a very compelling option. So one example of that is in my controller here, you can see that I'm referring to name as a URI parameter in this definition here, as you can see. And that's being injected with a name variable. So if I wanted to modify this to use my database, I can say find by name, and then create a method in here, which is find by name, which is essentially implements that use case. And I imagine right now, I don't know if my tests will still pass after running this. Oh, they do. Okay, well, that's good. I think my getPerson method is actually querying for Fred, which is one of the people we created in my application class startup event. So we're all good there. So the name variable here is linked implicitly to the name parameter here. So if I were to, for example, declare make a spelling mistake over here and use instead nam, or for some reason, a typical framework that is not Micronaut would fail at runtime with some horrible error. In the case of Micronaut, because we're doing everything at the compiler level, you will see that you get a nice compilation error saying the root declares 0 variable name, but no corresponding method argument is present. So you get nice compile time checking. And the same thing happens with Micronaut data JDBC. So if I were to use find by nam, and clearly there's no nam property on the person class, and I try and run that, you will, instead of the thing failing at runtime with a SQL error of some sort, you get a nice compilation error saying, I cannot do that because the person doesn't supply that. So we have some really nice compile time checking when you're using Micronaut, which just adds to the overall experience of using it. And another thing that you may not have realized is that this project is set up to include the Micronaut Open API annotation processor, which generates Swagger automatically. So whilst I've actually been compiling my class, whilst I've been compiling, it's actually been generating my Swagger definition for the API of the person controller. So this is the swagger.yaml, and there's the people endpoint, operation ID, points to the schema of my person class, which is all correctly computed from compilation time, which is all really cool. And you can expose that Swagger definition directly just through a little bit of configuration, which I already have in here, to expose the Swagger as static resources, essentially. And we have support for Swagger UI and all those kind of things. So that's pretty cool. Now, another thing about this application, looking at the build output, you'll see that there's a few other things in here. We have some services definitions. These are all generated at compilation time. This is essentially the bean definitions in your application. And if we look at the compile time produced classes, what Micronaut does is for every bean that finds, for example, the controller, it generates a compile time computed bean definition. And all these classes that start with $, which are essentially marked as internal classes, are essentially generated by Micronaut, which allow Micronaut to do things like invoke your controller without reflection, or instantiate the bean without reflection, and so forth. So that's essentially how Micronaut works, by producing those additional set of classes. Finally, if we wanted to take this class to this example and oops, I think I'm in the wrong directory. If we wanted to take this example and build it into some kind of distribution, what you can do, or compute it into a Grail VM native image, what you can do is assemble essentially a fat jar, or in the case of Docker, you may want to use Jib or something like that. And once we have the native image, the fat jar, what you can use is Grail VM native image to essentially just build a native image from it. So, and this will go ahead and take your produced jar file and produce a native image. Now, this is going to take some time, so I'm going to producing a native image is not the fastest right now. So I'm going to switch over to my slides so that we have time for Q&A and so forth, and talk a little bit about Micronaut 2, which is coming out tomorrow, and is a massive new release Micronaut, which includes so many new features. It's got a brand new native GraalVM computed command line interface. We have serverless support for Azure and Google Cloud Function. We've added incremental compilation support for Gradle so that you can compile as fast as you would, without Micronaut, incrementally. We have a brand new Maven plugin for Maven users. We have support for servlets, so you can go traditional and deploy a WAR file. In the Netty support, we've added support for HTTP2. There have been absolutely enormous improvements to our support for GraalVM native image. So we support all the SQL databases, all the SQL drivers. We support Elasticsearch, we support Redis, we support Neo4j. We support so many different things in native image now that you really have to look hard to find what we don't support in native image in terms of third-party libraries, which is awesome. And there's a lot more, and I recommend you take a look at our What's New guide. Check it out. And I also want to talk a little bit about Micronaut Launch, which I demoed briefly. So this is a UI for generating Micronaut applications. And it's actually, the front end is written in React, but in JavaScript, but the back end is written in, is actually the same as the command line interface in Micronaut, and it's written in Micronaut itself, and it's fully serverless and computed to a native image on GraalVM. And it's accessible via the browser or curl. And it's a really cool project because it demonstrates a lot of aspects of Micronaut, of using Micronaut. So I would recommend checking out the source code at Micronaut project/Micronaut starter. And it has, which is an interesting source repository because it demonstrates building from the same code base written in Micronaut, a command line interface that is built into native images for Windows, Linux, and Mac OS, plus a server application that is continuously deployed as a native image in GraalVM to AWS Lambda, to Google Cloud Run, and to various other Azure Function and various other serverless platforms. So a very interesting project if you want to look, for example, of using Micronaut and native image and Graal in general, check it out. In terms of the Micronaut itself, it is a healthy project, which has had so many different contributions already. It's been under active development for 3 years. We've had over 200 contributors. We've had contributions from major industry players like Google, Amazon, and Oracle. We have 3.8K stars on GitHub right now, over 8,000 commits. And please, go to the repository and star us. We appreciate the support. The Micronaut project is doing well and it's healthy and it's being adopted broadly by a lot of different companies. Some of the companies I can mention are Mojang, which is the company behind Minecraft, is migrating a lot of the backend to Minecraft and Micronaut. Target in the US, big US retail chain. SmartThings from Samsung, which is using Micronaut in the IoT space. So really, it's really taken off, and it's a good time to look at it. And I'll leave you with this, which is a statement that I believe to be true, which is essentially that the future of Java in terms of serverless and cloud computing and so forth is intelligent compilers and smaller, faster runtimes. I think that's being proven by things like Micronaut, things like GraalVM, and other frameworks developed by other companies that are taking similar or the same approaches. And if if you're looking for some other resources, if you want to come chat to us, we're on. Oops, I pressed something. Oh, there we go. On Gitter, that you can come chat to us on Gitter on the Micronaut framework. The link to Micronaut Launch is there. If you're looking for more help on specific topics, Micronaut Guides is a great place. Do follow us on Twitter as well, Micronaut FW, and do contribute to the code. It's open source. It's Micronaut framework, Micronaut project/Micronaut core. And with that, I have time for Q&A, which I think is going to be done through Discord. So I'll pop into the Discord chat, and thank you very much. Do connect with us. Thank you very much.
Thank you, Graeme, for this great deep dive. It was very refreshing, especially considering the temperatures in and outside. Great overview you gave about the impressive framework Micronaut. There are indeed some questions. I summarized some of them, so you don't have to do it. Let's start away with some quite detailed question about the modularity system used in Micronaut. So the question is, does Micronaut has module info files, so it plays nicely with GPMS, the Java Platform Management System, and can be used with JLink. So are these kind of related or not?
So the way Micronaut works, we do publish module info files, but we also have to balance that with supporting Java 8. But the way Micronaut works is very conducive to using in the module system, because essentially the way Micronaut discovers things at runtime is all through the standard Java service loader, which is obviously how the module system works, right? So we have a Swing project that's underway at Object Computing that is using the module system and Micronaut to great success.
Okay, cool. That's good news then. Another interesting question is, if you compare Micronaut to Spring, what would still be missing?
Well, I think that obviously Spring has been around for more than a decade, and there's clearly things that the Spring ecosystem has that Micronaut ecosystem doesn't. Many of those things I would regard as being legacy, unnecessary things. But there are definitely gaps that we are looking to still fill. I think people are asking us for better support for things like document databases in general and MongoDB. And that I think is an area where Spring Data is ahead. And I think in general, area of data, we definitely need to continue improving and evolving and making better. But the gap is narrowing, and for building modern applications, there isn't much that is missing from Micronaut nowadays.
Okay, cool. That's also good news. So what would be your advice? Say if you would switch from Spring to Micronaut, would you then advise to go hardcode Micronaut or use some of these glue projects like Micronaut for Spring so that you can still use your familiar annotations? Or just ditch that and, as said, go right away with the hardcore Micronaut? What would be your advice?
So, I would go straight in with Micronaut. I think Micronaut for the actual design purpose of Micronaut for Spring and the reason we built it was because of Grails. Micronaut for Spring, what it does is it lets you use Spring annotations to define beans and so forth. That can then be consumed by another application. And we had that requirement because we wanted to build certain projects that were able to share libraries between a Grails application, which is essentially based on Spring, and a Micronaut application. So Micronaut for Spring is great if you want to share code between a Spring project and a Micronaut project, and you can use Spring annotations to do that. But that library will work in Spring and that library will work in Micronaut. But I'm not sure I would, recommend necessarily using the Spring annotations in Micronaut itself. There's certainly it's certainly better to go all in on Micronaut, I would say.
Okay, excellent. That's a very clear advice. Another question that comes along is, what's the difference between Quarkus and Micronaut? Could you outline them?
Okay, yeah, sure. So, Micronaut came out I think 9 months before Quarkus or something like that on the calendar. So they are architecturally quite different. So the way Micronaut works is it's based on standard annotation processing, which essentially processes your source code. And so Micronaut processes your source code and produces additional bytecode. Quarkus's architecture is based on a kind of two-step process of compiling your code first and then running a post compilation bytecode enhancement step. This has certain implications, so some of which I demonstrated in the demo. So, for example, with Micronaut, we can provide really nice error messages that link back to your source code because we're processing the source code, right? So, if you're using the framework and something goes wrong, we can point exactly to the line of code where the thing went wrong. Whilst with Quarkus, that's much harder because they're not processing the source code; they're essentially processing the bytecode which has already been built. Another thing with difference is that we believe it's really important that you have a very isolated set of dependencies on your compiler class path. So when you compile with Micronaut, we have a very isolated annotation processor class path, which only has like three things on it in order to generate classes. And the reason that's important is because you really don't want your runtime class path on your compilation time class path. From my understanding of the way Quarkus works is essentially it puts your whole runtime class path into this bytecode enhancement phase. And I think that's going to be hard to scale long term because the last thing you want is like a no such method error happening in your compiler, and dealing with dependency conflicts and so forth in your compiler, which I think is going to end up happening in the case of Quarkus. Another difference is, Micronaut does not touch your bytecode. So, the classes you write are never the bytecode for them is never modified. It's using the standard Java compiler. Whilst Quarkus is doing some transformations and so forth, which I think is inherently less safe, in my opinion. And another difference is how that, in terms of using annotation processes, which is kind of like a Java standard. Well, it is a Java standard. It means we can integrate with Java C directly. And that means we don't need like special IDE plugins. So whilst a company like JetBrains right now is developing support for Micronaut, even before their support for Micronaut, there wasn't really any special IDE support needed because all IDEs currently understand annotation processing. Whilst with Quarkus, you have to use a custom build tool, you have to use a custom IDE, you can't run the application inside your IDE. So there's various implications of that custom build process that they've developed that I think are a little bit hostile in terms of IDE integration. But I encourage everybody to evaluate both frameworks and decide for themselves. I think Micronaut is great, and I know what its strengths are, but I think there's significant advantages of our approach.
So the architectural choices, as summary, they made in Quarkus are more likely to get some nasty errors and integration with your tooling than with Micronaut, which more plays with the current standard in that sense.
That's correct. Yeah, we have to integrate directly with Java annotation processes and Java C, and we're not introducing any kind of two-step compilation process, bytecode enhancement process, which requires special build tooling or anything.
Okay.
So. Yeah.
While we're at it, just another question pops in. If you would compare Micronaut with Helidon?
Yeah, so Helidon is I think Micronaut is a much more broadly applicable framework. Where we have support for building command line applications, message-driven microservices, serverless applications. All sorts of things. It's much more a general purpose framework, like with DI and AOP and so forth. For me, Helidon is more similar to something like Vertex. It's essentially a toolkit for writing microservices. So they're specifically targeting the microservice space, which is a good goal. They're focusing on that microservice space. But it's much more limited goal that they're focusing on. I think Micronaut is much broader than that.
Yeah, that makes perfectly sense. Okay, yeah, we have quite a detailed question left, but why not? We still have some time to answer them. So someone recognizes that you used in your live coding samples retention runtime for your annotations. How can this be?
Oh, well, it didn't actually have to be retention runtime, actually. Actually, it's actually a feature of Micronaut 2 that we added support for source level retention. so I probably should have just left it at source. Apologies for that, mistyped. I think it would work the same. If you want me to quickly check, I think it would work exactly the same if it was source level retention.
Okay, so this kind of reassures me too. That's, I think, a good addition.
Yeah.
And I think this will also conclude your impressive session. Thanks a lot.
Thank you. Well, thanks for all the attendees, and I'll hang around in the Discord channel a bit longer if anybody has any other questions that they want to ask me. And yeah, thanks for having me.
Thanks a lot too.
Thank you.